What is the challenge of NER in agglutinative languages? Imagine trying to find specific names or places in a language where words are like long, complex puzzles. That's what makes recognizing named entities in agglutinative languages so tricky. These languages build words by stringing together many small parts called morphemes. Each morpheme adds meaning or grammatical info, making the words very long and packed with details. For example, a single word might include a root, a possessive marker, a tense indicator, and a location suffix all in one. This means the same name could appear in many different forms depending on how it's combined. For a computer, spotting these variations is like trying to find a familiar face in a crowd where everyone is wearing different costumes. Tokenization, which is breaking down text into manageable pieces, becomes a real challenge here. If the system doesn't split the words correctly, it might miss the entity or think parts of it are separate. This can lead to mistakes in recognizing names, places, or organizations. Another big issue is that many agglutinative languages don't have enough labeled data for training artificial intelligence models. Without enough examples, the models struggle to learn the patterns needed to identify entities accurately. Plus, building tools like morphological analyzers that can understand the internal structure of words is often expensive and time-consuming. Words in these languages can also be ambiguous. A single form might have multiple possible meanings or grammatical roles, depending on the context. Disambiguating these forms requires sophisticated models that can understand the entire sentence, not just individual words. Agglutinative languages also have special features like grammatical cases or possession markers that change how entities appear. Recognizing entities in these contexts means models need to be tailored specifically for each language, rather than just applying a one-size-fits-all approach. From a machine learning point of view, traditional models that work well with languages like English need adjustments. Using deep learning models that consider the internal structure of words, such as contextualized embeddings, can help. These models can learn to recognize different forms of the same entity by understanding the morphological clues within words. Improving NER in these languages can lead to better information extraction, smarter search engines, and more accurate question-answering systems. For example, AI tools like ChatGPT can better understand and generate text if they handle the complexity of agglutinative languages well. In short, the main challenge is managing the rich and variable morphology that makes words in agglutinative languages so complex. Overcoming this involves combining morphological analysis with advanced machine learning techniques, creating language-specific resources, and developing smarter tokenization methods. This way, we can help AI systems recognize entities more accurately, even in the most morphologically complex languages.